Hey guys, we are going to talk about lesson 1. And if you have not watched the introductory video, please do so because it talks about elements and unions and intersections and all this good stuff that I'm going to refer to in this lesson, but we kind of already went over it in the intro lesson. In this box, I'm just going to talk about a couple things that I didn't really have a chance to talk about in the intro video. So we talked about sets. There are two types of sets that I didn't talk about. The first one is a finite set, and then the second one is an infinite set. So like a finite set, an example of that would be like 1, 2, 3. So you say, how many elements are in this set? There are 3 elements in that set. Easy peasy. But an infinite set, that's a little bit more difficult to describe because a lot of times you can say 1, 2, 3, ... and that means 4, 5, 6, 7, 8, 9, 10, 11, 12, all the way to infinity. So there's not a number that I can place on this, a number of elements on this set. So that's the difference between the two. Please do not get infinite sets mixed up with a set like this. So notice this is just kind of shortcut of a finite set. There are 9 elements in this set, 1, 2, 3, 4, 5, 6, 7, 8, 9. But the ... that kind of is just a shortcut to tell you that all the numbers in the set are included. In this lesson, I try to stay away from getting too mathy in the intro lesson. So in this lesson, we're going to get a little bit more mathy. So remember in the other video, we talked about roster forms. That's listing it. I want you to tell me what roster form would be for this set builder notation. So remember, roster form is just listing, set building is describing it. Okay, so x such that x is a natural number less than 20, so that's not including 20, and divisible by 3. Okay, a natural number. In our next lesson, we're really going to talk about what the number groups are. But a natural number, those are the numbers that you learned when you were in preschool. So like starting with 1, 1, 2, 3, 4, those are natural numbers. Okay, so let's go back. A natural number less than 20 divisible by 3. So think about this. We're going to count by 3. So let's see. 3 is divisible by 3. 6 is divisible by 3. 9, 12, 15, 18, 21. Oh, nope, 21 goes past 20. So this would be the roster notation for the set builder that it gave us. So I want you to go the other way. This isn't your example for set builder right here. And I want you to apply that to this example that's in roster form. So go ahead and do that. I'm going to push pause and see what you got. Okay, so the way I said this in set builder notation is x is an even natural number. Remember, like counting numbers, so we're keeping it basic, greater than or equal to 10. Now, you definitely do not have to say that. So like you could have said x such that x is an even natural number greater than 8, because that would include 10, 12, 14. And there's some other things too. So it's kind of open-ended to a certain degree. So you'll kind of learn a little bit more as we go along. It is definitely not like one right answer and that's it. So what I want you to do is make up your own set and write it in both roster notation and set builder notation. Okay, so I got away from the math on my example. So I was just thinking about the first thing that came to my mind is the Simpsons show. So we have Bart, Lisa, Marge, and Homer in roster form. And I have in set builder notation, X is a member of the Simpson TV family. Oh, and there's a baby too. I forgot the baby. Please forgive me. Okay, so if you will remember back to my last video, the intro video, that little symbol right there, that means element. So 3 is an element of A. So on each of these, we're going to deem them as true or false. Something else that I did not mention in my video is that you can also have not an element of A. So while this is an element of A, this is not an element of A. And that works equally as well for like the subsets too. So I want you to go through, think about what we talked about in the intro video and see if you can answer those as true or false. Okay, so the first thing I did is I took the set builder notation and I turned it into roster notation. I just thought it was a little bit easier to do. Okay, so let's look at A. So 3 is an element of A. Well, let's look at A, and 3's there, so that's true. B, 4 is not an element of A. So A, yep, that's true as well. 5 is an element of B. Oh, I don't see a 5 here, so that is false. A is equal to N. Is equal to N. So, okay, so we haven't talked really about equal sets. So equal sets are the exact same number in both sets. So the set of A has 4 elements. Think about the set N. So remember, set N is the natural number. So the set N has a huge amount of elements, right? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So those sets are not equal because what's inside the set is different. So that's false. Okay, let's look at this. B, the set B is equal to 2, 4, 6, 8. Well, let's go up here. So we have B is equal to 2, 4, 6, 8. So that is true. Okay, now we have one in set builder notation. X is a natural number less than 6. And so this is, we're talking about set A. So a natural number less than 6, that would be 1, 2, 3, 4, 5. And so I'm going to look up here, and that's not true because we're missing the 4. So that is false. Okay, let's keep going. So we're going to kind of refresh our brains on union and intersection of sets. So we talked a lot about that in my last lesson. So I just want to hit some weird situations. So when you have nothing in common, that's when that empty set comes up. So if I had the intersection of A and B, well, there's nothing. They're not intersecting at all. So that would be the empty set. Sorry. So nothing exists. No elements exist there. Into some more things with the empty set. So if I have like the unions, remember that's like everything coming together. The union of A and the empty set, which you will see. Okay, so think about, we have the set A, and then we have this like, so here's our set A. We have this invisible empty set over here. So union is everybody coming together. So that is going to equal set A. Okay, but if we have the intersection, that's what they have in common. Well, since A and the empty set have nothing in common, that is going to be equal to the empty set. So it kind of hurts your head if you think about it, but just keep those two concepts in your brain, and that'll help you out sometimes. Also, some people want to use that as the empty set or this as the empty set. Both of these are wrong, and the reason is this one is not a set, and this one has actually one element. It has the element of 0, so then it would not be the empty set. So just make sure that is the best way to use the empty set. Okay, now let's practice union and intersection of sets. So go ahead and see what you remember from that. Remember, union, that's everybody coming together. Intersection is very small, what they have in common. Okay, so I won't go through each of these. Just know, like for this one's kind of a weird one. So A had 0, 2, 3. C had 7 and 8. So when they don't have anything in common, that's what this symbol means, then we're going to put the empty set there. Okay, so I want you to look at this. This is kind of another concept that makes you think. So we're going to determine whether they're equal, not equal, or is an element or not an element of. So go ahead and see what you can do, and we'll kind of go into each of these. Okay, so the first thing that I did is I wanted to see what that set looked like in roster form. So the union of A and B is this, and the intersection of A and B is this. I also want to point out the difference between like element and equal or not equal to is an element deals with like a member of the set, whereas equality deals with different sets. So like this is a set comparing to this set. This is a set comparing to this set. So these are either equal or not equal, while these up here are either elements or not elements. So I just wanted to make sure that you understood that difference. Now we're going to move on to subsets, which we talked about in the other video. But I just want to be clear that subsets are kind of like equal sets. So if I had like the set 2, 3 is a subset of 2, 3, 4, these are both sets. They're not elements. Like 2 is an element of a set and 3 is an element of the set. But when we're talking about subsets, we're comparing the whole set to each other. So don't get it confused with like using elements. So you need to make sure that you have the little curly cues denoting the set at all times. And also, I want you to know that the empty set is a subset of every set. So this is kind of important to know. So make sure you don't forget that. That kind of will show up sometimes. Okay, so let's kind of practice subsets and see what happens. So the only thing that's false, their only problem that's false is this one. So if you'll notice, like this is a set comparing a set. So we have a smaller set going into bigger set. So that's true. Here we have a bigger set going into smaller set. So it says it's not a subset. So that's true as well. The problem with this one, it's actually true because it says it's not a subset. The problem with this one is this 3. So this set had this 3 in it that was not a part of this set. So it could not be a subset. This one, the 6, was in this set, which was not in this set. So it was saying it was a subset, which is false. And then, just like I said before, the empty set is a part of every subset. So that was true. So the next thing we're going to do is talk about when you have 3 sets. So we, in our Venn diagram in the intro video, just had 2, but now we're going to have 3. So think about this from an algebraic perspective. So I'm going to start here, get that union, and set it in roster notation, and then find the intersection between that and C. So I'm going to set it up and show you here. So the union of A and B is all of this. And so we're going to show the intersection of C is that. So what I'm asking myself is what they have in common. So they have a 4 in common, they have a 5 in common, and that's it. So my final answer is 4, 5. So try the next one. Okay, so here I found the intersection of B and C, which was only 5. So that set only has 1 element in it. And then A is this. So the union is everybody coming together. So this is my final answer. Okay, so for this last section, I want you to just practice using the symbols that we've talked about in this lesson. Most of them are pretty self-explanatory. The only thing that I want to talk about is this. I purposely use the word member because every once in a while you'll see that in a textbook. So instead of them using the term element, they'll use the word member, and that means the same thing. So element and member are the same things. Usually you'll see element, but I just wanted to throw that in there real quick. So that is all of lesson 1.